So once you click on this Weka icon, the Weka software will start, and this will be your first Weka page, which is a Weka GUI chooser. In order to use our techniques in Weka, you need to go to the package manager to install our algorithms in Weka, and you need to do a refresh repository cache to make sure that all Weka packages are available before you look for them. So at this stage, you can search for our techniques, which is one of them is sys4, and then you will find sys4 there, and after that you need to install sys4. So I'm restarting Weka again after the installations. It's coming up. Now we need to go to Explorer, Weka Explorer. Now you are ready to use your Weka software on various datasets. The first thing, of course, you need to upload a dataset, the dataset that you want to use for knowledge discovery or building decision trees, etc. So you go to open file. You know your dataset, but I can actually also download any available dataset already in Weka. So in the Weka software that you have just downloaded a few minutes ago also comes up with some datasets in it. So you go to the data page, and there are a lot of datasets. The extension of these datasets are ARFF. It is very similar to any .txt or CSV dataset. So here we have a dataset called diabetes dataset. So we just open the diabetes dataset, and then it shows up the attributes of the dataset. This is the class attribute, and this is tested negative or tested positive, so whether a patient has diabetes or not. And you can see the distribution of the classes. So the negative, tested negative 500, so there are 500 records, so the blue is negative and the red is positive, so you have diabetes, a patient has diabetes or not, that sort of thing. Now this is the data set, but now if I want to build classifiers, I need to go to classify and choose classifiers. And if we are looking for tree type classifier, remember we just installed sys4 a few minutes ago. So when we try to choose classifiers, we can see sys4. We can also see forest PA. So forest PA is also available. So you can build either sys4 or forest PA. You can build multiple of them. So let us first show how to do sys4, and then this is our data set. We have our data set, that's the diabetes data set, and now we are classifying that data set by sys4. Sys4 has some default setups. You can actually have a look. For example, here minimum number of record in a leaf is 10. We can make it 20. Number of trees are 60. The more the better for prediction accuracy, generally speaking. So let us, for simplicity, make it 10 to start with, and then start. So here what will happen is immediately it will build 10 trees. So you can see tree number 10, and this is tree number 9, 8, and so on and so forth. So what it does, this tree number 1, I will explain what does it do. It says the plus is an attribute. If you look at the class, the data set details, you will see that plus was an attribute. This is plus attribute, and the distribution of plus attribute is like this. So red is diabetes and blue is not diabetes. So you can see that plus value, when it goes higher, then the chance of diabetes is high. When the plus value is low, then the chance of diabetes is low, red is low, that sort of thing. But it is very difficult to identify these things in plain eyes. Now we can back check it, cross check it, because we can see that the tree has identified plus. So it says that if plus value is less than 166.5 and the mass value is less than 26.3, then tested negative. That means the high chance that the patient will not have diabetes, and there are 159 such cases that has plus less than this and mass less than this, and only 9 of them are actually tested positive. So 150 over 159, that many records do not have negative. So this is a knowledge that you can discover. You can study this for further knowledge discovery, and you can build many trees. You can actually build as many trees as you like. Say, for example, number of trees, you could say 100, and you restart it. Then you see that there are 100 trees now, tree number 99 and tree number 100. And then you can build your forest P algorithm as well. So here, now you have 10 different trees again, and tree number 0 is the first tree, and this is a forest PA tree. Okay, and you can see knowledge from here. If age is less than 27, tested negative, the chance is high that the patient will be negative, which makes sense. Younger people generally do not have diabetes. So this is how you can use different classification algorithms to build decision trees from Weka. So this is how we can see the rules there. But the problem for knowledge discovery is there are so many rules, because we have built 60 trees. We could build 100 trees, few hundred trees, but from those decision trees there are so many rules that it becomes very difficult for a data analyst or an end user to find out important rules, interesting rules. That is why today I will demonstrate a new software that we have uploaded called Forex++, and how to use that in order to discover more useful rules first. Now, in order to use Forex++, you have to choose that software first, and you need to install the software as I demonstrated before. So for installing Forex++, you need to go to the tools of your standard Weka, then go to package manager, and then when the package manager screen appears, then you have to go to the available radio button, click the available radio button, and you may actually then see all the available packages there and search for Forex++, and you will find Forex++. Then you have to choose and install. So that will make Forex++ installed, and once it is installed, you may need to restart Weka. Once you restart Weka, then if you go to the package manager again, then you will see that Forex++ is installed already. For example, here now when I click the installed radio button, I can see Forex++ there. So Forex++ has been installed that way. Now you have to open the Explorer again, and of course you have to open your desired dataset. In this case, I will be opening the diabetes dataset again. Now if I want to open Forex++, I will go to classify and then choose a classifier. It's not a tree, it's a meta classifier, and because you have installed Forex++, you will see Forex++ in the list. You choose that, then Forex++ is actually being used now. Now when you click on Forex++, you will see various parameters that you can set for Forex++. The Forex++ is an algorithm that we published recently that can use theoretically any existing decision forest algorithms to build a number of decision trees. In my previous demonstration, I showed it was a problematic thing when you have 60, 70, 100 trees, so many rules. And the trees can be built using existing algorithms like SysFor, Forest PA, random forest, bagging, boosting, etc. Now for X++, once these trees are built using an existing algorithm, can actually pick best rules for you. So the problem that we faced before, so many rules, is kind of handled here. So here for X++ in our implementation in Weka, you can also choose a classifier. Okay, so by default it says sys4, but at the moment we have implemented it for sys4, random forest and forest PA. You can choose any one of them. Let's choose sys4, and then if we click on it, then this will help you to determine sys4 parameters. For example, number of trees, we had 60. Let's say we now build 5 trees. You don't have to, you can keep it 60 or even keep it 100, but we are just demonstrating that you can actually choose sys4 parameters. Minimum record in leaf, let's say 50. I'm changing some parameters in sys4. Now in for X++, there is a parameter called print classifier false. You can turn it to be true so that you can actually see the trees and leave them true. So it is using both all of the parameters like accuracy, coverage and rule length to choose the best rule sets. Now after that, when you start for X++, it finished already. It has done its job. See, I chose 5 trees. It has built those 5 trees. So in sys4, if you remember, I chose number of trees 5. It built those 5 trees. If I chosen 60 trees, it would build 60 trees. And the problem that we faced before, so many rules. Now if we go up, you will see that it has actually identified only few rules for us that are interesting. So from tested negative class, it has found 7 rules. Each line here is a rule out of these trees, and from tested positive class, it has found 2 interesting rules for us. Now you can also, after you identify some interesting rules, you can also explore surrounding those rules to see what are the information there. So to explore the other side of the rules, or when you identify some rules, you can then decision trees and forests can help you to identify interesting rules like this, and this you could find without any pre-assumption, any domain expertise in that sense. So this knowledge, these rules are coming out automatically from decision forest, and then you can identify that maybe this is one interesting rules because it says plus greater than 166.5 means positive. Now what is if it is less than 166.5? What is not 166, 150? So can I discover knowledge? And then for doing that, here I have opened the file, the dataset in Microsoft Access, and let us write some query to see what is the class distribution when the class plus value is actually not greater than, rather less than 166.5. So I'm writing some basic SQL query here. Diabetes dot plus is actually less than equal to 166.5 instead of greater than, because that rule says greater than. So I'm now checking if this is less than, what happens. Dot class equals tested negative. So I'm trying to see like how many records are actually tested negative and how many records are tested positive when plus value is less than 166.5, whereas this rule says plus value is greater than 166.5. So once I now complete this query and run this query, I can see that there are 489 records with negative class values, and similarly I can run this query again to see how many of them are positive, and then I can see there are only 200 positives. So from this I can see a class distribution when it's actually
different. The plus value is different, and then from that I can write an Excel file like this with the new class distribution. So when case 1, then this is the percentage of positive and negative. Case 1 means this rule, and case 2 is this other query, and I can see the distribution difference. So when plus is greater than 166.5, then there is a huge number of positive compared to negative, whereas when plus is less than 166.5, then there is a very big number of negative compared to positive. So I can actually discover this sort of knowledge from this. So this is and this is a simple demonstration. You need to do it more and more to actually learn more about the data set. Data mining and knowledge discovery is mostly about making sense of data. So you can actually keep exploring these things and learn more and more knowledge.